In Chapter 5, you're going to be studying two-stage cost allocation and activity-based costing systems. Both of these are essentially pooling a bunch of indirect costs and assigning them to particular components of the business, jobs that the business does, etc. Slight difference being what indirect costs you are actually accumulating into your pools. So let's begin with two-stage cost allocation. And this concept of it is something that you've seen before. You are going to be able to directly trace all of your direct costs to your cost objects, to your jobs, your products, your customers, etc. And then you're going to have a bunch of indirect costs that can't be directly traced to these different components over here. So you're going to have to pull them up and allocate out those costs from the pool in some fair methodology to the different elements of your business using a predetermined overhead allocation rate. To do so, you're going to have to identify a cost driver. It's the variable that has the strongest relationship with those indirect costs. What is causing those indirect costs to be incurred? And you can choose your cost driver for each pool that you have. Under a single system, you'd put all the stuff into one pool. You'd put in this simple system, as they call it, all of your indirect costs into one overhead pool. Find the aspect that is causing those costs to be incurred out of all of the different things your company has. It could be labor costs, could be labor hours, could be machine hours, could be pounds of materials. Use whatever you wish could as your allocation base. Declare that to be your cost driver and use how much each component used of your driver to spread out those costs proportionally. So that's the two stages in two-stage cost allocation. In the first stage, you accumulate all of the costs that go into a pool, and then afterwards you spread them out to the different objects that you are tracing cost to using cost drivers. The simple system uses one pool and one pool only, which presents a little bit of a conundrum because not all indirect costs are driven by the same thing. Indirect material usage is kind of tied to how many materials you're using. So maybe direct material quantities used would be the best driver for assigning the cost of indirect materials. However, depreciation, maintenance on machines, etc., is pretty tied to how many machine hours, how often you're running those machines. So maybe that would be a better cost driver for those particular elements of your indirect costs. Well, there's no rule that says you have to use one simple costing pool, one universal pool, like company-wide for all of your manufacturing. You definitely have the power to go and to create a bunch of subdivisions of these pools. And for each one of those pools, find the best driver you possibly can for the costs that are unique to that pool, and this will allow you to have a more accurate way to spread those costs fairly to the different cost objects that you have to make them more accurately costed. So over here we have Skyrite. They are a fake company that produces two models of drones. They are going to produce approximately 4,000 photography drones and 1,000 racing drones during this month. Well, in the process of doing so, they've got a bunch of different indirect costs that they're going to incur that go into the production of both of these models. So they've got $100,000 of indirect materials, $50,000 of QC costs, so inspection to make sure that nothing's defective, $150,000 of other indirect labor, $150,000 worth of equipment maintenance, so paying the repairman to go in and fix these things, all the lubricants that you need to keep the machines running, any bolts or nuts or whatever that come loose or snap that need to be repaired, all of that stuff would total up to 150,000. And then they're estimating that they're going to record $50,000 worth of depreciation on their equipment, so their total overhead would be $500,000. Well, this has to get spread out amongst the two different models to make the photography drone and the racing drone. Well, we've got a bunch of estimates, standards, if you will, for these two different models. We know how many units of each we're going to produce. We know the amount of labor costs, labor hours, excuse me, that go into the production of each unit for each respective model. We know the amount of labor hours that it's going to cause us to incur in total. So 4,000 photography drones at an hour and a half apiece would cause Skywrights to have to utilize 6,000 direct labor hours, and 1,000 racing drones at 2 hours apiece would cause them to utilize 2,000 direct labor hours for a total of 8,000. But they also have some machining requirements to go through and cut the pieces that need to go into the drones or to help assemble parts of the drone, the chassis, if you will. And for a photography drone, it's only a half an hour to machine. While the racing drone is much more machine intensive, that's 3 hours. But if you take the number of units that you're producing, multiply it by how many machine hours it's going to take for each unit, respectively, it's going to give you the total machine hours that need to be committed to the different models that Skyride's going to make for a total of 5,000 hours. And this is a good spots to talk about this conundrum we have between single and, two-stage allocation systems, multiple different pools. If we only want to use one single driver to put this $500,000 worth of overhead into these jobs, and the two yellow areas are our options over here, well, it's going to greatly dictate, if we only use one driver, how much of this overhead goes to the photography drone and the racing drone, because they're pretty similar in terms of direct labor hours. So if we use that, it'd be spread fairly evenly. But for machine hours, if we declare that to be our cost driver, well, the racing drone takes 6 times as much machine hours as the photography drone does. And subsequently, you're going to have 6 times as much of this overhead applied to the racing drone that you would to the photography drone. So let's see what things look like over here. If we use one of these items over here, we get our predetermined overhead allocation rate. If we spread that $5,000 in overhead out using direct labor hours as our driver, well, between the two models, that's 8,000 direct labor hours we're going to need. That's 62.50 an hour when you divide 500,000 by 8,000. That is how much overhead we would take out of the pool and put into each respective model's cost for every hour of labor that is direct labor hour, I should say, that is used for the production of that model. If we go down here, we can figure out how much in total is going to go into each different product. The photography drone takes an hour and a half of direct labor to produce. Well, it's 62.50 an hour times 1.5 means that if we use this methodology, for every hour our laborers work, for every unit they produce, we're going to end up putting in $93.75 of overhead. For the other model, our racing drone, it's $62.50 per direct labor hour, with each one of those taking 2 hours. That means every racing drone that we produce is going to assume that we spent $125 in overhead costs to manufacture it. So the racing drone is getting more, but it's not a huge difference spread between the two. Well, what happens if we make it a little more refined? Instead of having one pool with one single driver, let's go and look at the nature of our indirect costs, make multiple different pools, and come up with a unique driver for each pool. So in this case, we have a couple of costs that we can throw into one pool over here. And the first one, if I back up a little bit to what we had, indirect materials are going to go up the more units that we produce, and also quality control cost. Inspecting the units we produce is going to go up the more units that we make. So it makes sense to group those two together. And if we do so, we'll put $150,000 into that pool. Keeping indirect labor in a pool by itself, $150,000, we can have that be our second pool. And this first pool that we had should be based on the number of units produced. Well, indirect labor might not make sense to use units produced in this case because some units are more labor intensive than others. So we're going to assign direct labor hours as the driver for indirect labor. And then lastly, we have our equipment maintenance of 150,000 and our expected depreciation of 50,000. That's $200,000 in total. Well, it makes uh, these costs of maintaining and depreciating your equipment go up how often you use them. So it makes sense to have machine hours as your driver for that pool. So now we've got 3 different pools in here, each with its own unique driver. And if you go through over here, you can figure out how much cost would go into each unit that's produced. Under this simple system where we have just one overhead pool, we already determined that each photography drone would have 93.75 in overhead assigned to it, while each racing drone would have 125 assigned to it. Well, how is this going to differ if we use a two-stage, more refined system? Well, now we got a whole bunch of numbers going on over here, but we end up with $78 and rounded off 13 cents of overhead that would go into every photography drone, and $187.50 overhead that would go into every racing drone. That is a pretty significant difference from these numbers over here. It's a much, much higher allocation, all the way from 125 up to 187.50 that goes into each racing drone. So how did we arrive to those numbers? Well, the math's all up here, but let's break it down step by step. In this two-stage system that we're going to use with multiple pools, we grouped our things together and we assigned from those three different pools a unique driver for each one of them. One is using units produced, one is using direct labor hours, and one is using machine hours. We have $500,000 of total overhead costs that we have to assign, but that 500,000 is now broken down between three different categories: your indirect materials and quality inspection, your indirect labor, and your equipment maintenance and depreciation. Well, we're going to apply the same concept, and now each pool gets its own driver. The total amount of indirect materials and QC cost added up to 150,000. The driver for that pool was the number of units produced between both models. We're making 5,000. So 150,000 spread out among 5,000 units means that $30 for these unit related MOH costs that we have would be assigned for each drone that we produce. For our indirect labor cost of 150,000, we would declare that our direct labor hours would be the best driver between the two different models. We're going to have to use 8,000 direct labor hours. 150,000 divided by 8,000 gives you 1875 per direct labor hour. So for every hour laborers work on a respective drone line, not only are we assigning their labor cost directly to the model that they're producing, but we're also going to assign $18.75 of indirect labor coming out of this pool to that model. And then for our equipment-based pool that we have going on over here, that's a total of $200,000 worth of costs, our equipment maintenance and our equipment depreciation added together. We have chosen here to use machine hours as our driver, and between these two different models, that chart previously in the presentation said that between the two different models, we're going to use machines for 5,000 hours. So $200,000 of overhead spread out over 5,000 machine hours comes out to a rate of $40 per machine hour. So if we sit down and spend an hour making a certain model of drone at our machines, well, we assume that that just cost us $40. And we would assign that $40 to the cost object to that particular drone model. So in this system, we came up with these very, very different numbers than what we had before. Backing all the way up to the thing, that's how we arrived at these figures. Each one of these was just the quantity of the driver used in each model times the allocation rate that we just determined. And we came up with a theory here that these racing drones are causing us to incur much more in overhead costs than the photography drones. And it kind of makes sense. I bet you these are much more detailed. There's a bunch more parts that go on here. Well, if there's more parts, we need to use more indirect materials. If there's more parts, it's going to take longer to inspect, so we'd have more quality control costs. If it takes, more time to produce this more technologically advanced unit, if you will, we're going to have our workers spend more time producing them, which is going to cause our indirect workers to have to spend more time supervising them, cleaning up after them, making sure they're secure, etc. And then this is much more machine intensive, like way more machine intensive than photography drone. We'd have a ton more machining costs, maintenance and depreciation that went into the racing drone. So if this thing is causing us to work more hours and use more machine hours and have a more detailed inspection that it requires, it should cost more in overhead costs. And this two-stage system definitely did that. Much, much higher over here. So flipping back to the end over here, that's the difference between the two. Neither of these are what they're actually costing us. We are making guesses based on overhead costs that we don't know and we probably won't know during the period. It's really hard to know how much you're going to spend exactly on maintenance or how many hours in total you're going to run machines. So you allocate overhead based upon your best estimate. So while this isn't a perfect guess, that's not to the penny correct information, it is, however, a much more refined guess than using that single system where we just had all of the stuff in the pool, one singular pool being assigned by one cost driver, direct labor hours. It is definitely going to give you a better prediction of what these units are costing you, and you'll have less variance from period to period, in the cost of the units that you're making, or as they call them, cost distortions. And this should theoretically reduce the amount that your models can be overcosted or undercosted in any given situation. So for our example over here, we had under the single stage system, the photography drones being assigned much more overhead than they were in the multi-stage or two-stage system that we had. That single stage system would have made them overcosted. Inversely, the racing drones that we had over here would not have had enough overhead in them, making them undercosted. And that could affect us when we have pricing points that we have to consider, et cetera. We want to make a certain profit margin on each unit. Well, if you want, you have a target profit margin you're working towards, you definitely want to know how much each one of those units is going to cost you in the long run.